Hi guys, I trust that you're feeling well and awesome. Welcome to this video on grade 11 mathematics, and in this video we're going to have a look at inequalities. Now I've already uploaded a video on grade 10 inequalities, solving linear inequalities. So if you have not yet checked out that video, please do check it out and then come back to this one, as the knowledge that you've learned from that video will build on what we're going to learn in this one for grade 11. So we will have a look at what linear inequalities are, what quadratic inequalities are as well, because grade 11 work is concerned with quadratic inequalities. So first of all, we'll just do a brief overview of what quadratic inequalities are, how to solve them, what the similarities between quadratic and linear equations are. Then we'll look at the actual implementation of the solving of linear equations. So without any further ado, let's get into it. So in grade 10, you were introduced on how to solve linear equations and inequalities. An example of a linear equation would be something like 6 minus 3x is equals to 4. Then if we convert this into an inequality, or if we have an inequality, we would have something like 6 minus 3x is less than 4, just as an example. These are said to be linear equations and inequalities respectively, due to the fact that the highest exponent of the variable, the highest exponent of x, is 1. And so now in grade 11, we go and we take this a step further by introducing how to solve quadratic inequalities. So what is a quadratic inequality? Well, it's very similar to a quadratic equation where you've got something like x squared minus 3x plus 4, and then this is greater than or equals to 0. Now, if you have not yet checked out our video on how to solve quadratic equations, please do go have a look into that video. I will leave the link down in the description, and you can go check it out so that you know exactly how we would solve quadratic equations, because we will use the same techniques here in this specific video to solve the quadratic inequalities. So, quadratic inequalities, as we've said, are solved very similar to how we would do quadratic equations, and hence I recommend, if you have not yet checked out our video on solving quadratic equations, please do check it out, then come back to this one, as the techniques that you've learned there will be applied here as well. So now what you need to take note of is the quadratic inequalities must absolutely be accompanied by a diagram. There are cases in which a linear inequality does not need a diagram. But when we're looking at quadratic inequalities, in as much as the statement will not say show your answers on a number line or in the form of a diagram, just know that you have to use a diagram. It is vital to use a diagram for you to be able to get the signs correct. Secondly, the inequality sign depends on how the diagram is structured. If this does not make sense as yet, don't worry. Once we get into the construction of the diagram, you will then understand what we mean by the statement. So, let's look at how to solve quadratic inequalities. The first thing we need to make sure is that our inequality is written in the form ax squared plus bx plus c. So if you have anything else that's not of this nature, you want to make sure that we have it in the form of a quadratic equation. In some instances, the exception would be if it's already factorized. I'll give you an example. If you've got something like x into x plus 6, let's say this is less than or equals to 0, you would then just take this as it is and then solve for x. However, in any other case, you want to make sure that you have it in the form ax squared plus bx plus c. We then need to find the critical values. And basically, the process of finding the critical values involved that you solve for x as if the inequality were an equation. We would then have to place the critical values on a parabola that is concave up. Please take note of this. The parabola must always be concave up. Some of you would say a smiley face. That's okay, that's cool. Although I don't really see a face here. But nevertheless, we need to always make sure that our quadratic equation, our quadratic graph, is concave up. Now, some of you might be arguing, or some of you might have been told to say, no, it is possible for the graph to be concave down, especially if the coefficient of x squared is a negative value. Well, that is absolutely true. But for the purpose of this video, we always need to make sure that our graph is concave up. It's simpler that way, and I will show you how to make sure that the graph is always concave up. The next thing is we need to check the inequality sign of the original expression, and then we need to place the signs next to the critical values according to the sections that we found on the graph. That was a lot of talking. Let's actually get into the working. So here's our first equation, and we need to solve for x here. So let's go to the writing pad, writing board, whatever you want to call it, And let's solve for x here. So we've got x squared minus 6x plus 5. This is greater than or equals to 0. Now, as we've mentioned, we need to solve this as though we are solving an equation. So what I'm going to do is I'm just going to indicate up here, we're pretending like this is an equation. We'll have x squared minus 6x plus 5 is equals to 0. Now, if we look at it in this fashion, we know that we can open two brackets. We can factorize the expression. Please take note that you could do the same thing as completing the square or using the quadratic formula. That's absolutely fine in finding our values of x. I'm going to have x here, I'm going to have x here. Factors of 5, I'm going to take negative 5 and 1. Right. We are done simplifying the expression. The next step is we need to find the critical values. Now, we said earlier in our notes that we need to solve for x as though this is a quadratic equation. So in other words, if we look at the section up here in blue, we could do the same factorization. X minus 5 into x plus 1 is equals to 0. When we solve for x here, we will get x is equals to 5, x is equals to minus 1. So I'm going to take these as my critical values. So we're going to say x is equals to 5, and then x is equals to negative 1. Now we need to go ahead and place this on a number line. So we're placing it on a parabola / number line. Let me get my double arrow going here. There's our x-axis. We are drawing a parabola that is concave up. Now, here's something you need to take note of. We have, let me make it in bold so that it stands out. We have a positive sign here. We have a negative sign, we have a positive sign. Why is it like this? Well, think of it this way. When we look to the left of our x-intercept here, the graph is going up, and that's why we've got a positive value. When we look at the right of our x-intercept on this side, the graph is going up, that's why we're putting a positive. Your graph will always look like this. Please take note of that. Now we need to place our x values on the graph. So negative 1 is going to be there, and positive 5 is going to be there. Now, let's pay attention to the sign in the original question. If it says greater than, you must always focus on the positive side of the graph. So, let's do this. Let's put x there with the space and then minus 1. X with the space and positive 5. Right, since we have determined up here that we are looking for the positive section on the graph, when we're looking at negative 1, let me use a different color for this. So, when we are looking at negative 1, notice that to get to the plus sign that we spoke of here, we need to go to the right. There is our plus sign. Sorry, to the left. There is our plus sign. But when we are moving to the left, the x values are decreasing. The x values are less than. And therefore, I need to put x is less than or equals to negative 1. I hope that that makes sense. Let's go to x is equals to 5. We are right here. We are still looking for the plus sign that we highlighted up there. To get the plus sign, we need to move to the right this time. There's our plus sign. Now, as we are moving to the right, the values, the x values are increasing. So x here is going to be greater than or equals to 5. There we are. We have solved our inequality. Life is great, you guys. Now, please take note of something. Your signs will always face opposite directions. If we have a less than in the first case like here, we will always have a greater than in the other end. It will always be the same. Your signs will never face the same direction. Signs will always have different directions. Please take note of that. Let's look at the next question. So, in our next question, we've got negative x into x minus 2 is less than 0. So let's go to the writing pad and let's write this question down. So I should probably do this right underneath. So we have got negative x into x minus 2, and this is less than 0. Now, as I've mentioned to you in the notes, some people will say to you the coefficient of x is negative, so the graph will be concave down. Now what do I say? I say, let's divide by -1 both sides. And if we divide by -1, notice this is going to cancel. We're going to remain with x into x minus 2. When we divide or multiply by a negative sign, the inequality sign changes direction. This is going to be greater than 0. Once again, we are going to pretend like this is an equation. So we're going to have something like x into x minus 2 is equals to 0. And by so doing, we are able to get our critical values. Our critical values are going to be x is equals to 0 and x is equals to positive 2. Once again, let me draw my diagram. So there we are. This is a curve which is concave up once again. And take note of something. This is plus, this is minus, this is plus. Graph is always like this. Now on our x-intercept, we're going to have 0 and 2. Please take note, the smallest x-intercept is always the one that's placed to the left. And the biggest x-intercept is placed to the right. Okay, let's focus on the new sign that we have here. This sign is greater than telling me I need to look at the positive on the graph. Now, I am at 0. Before I get there, let me just write here x and 0 with the space, x and 2 with the space. I am at x is equals to 0. To get to the plus sign, I need to move to the left. There's my plus sign. When I am moving to the left, x values are decreasing, so x is less than 0. Awesome. Then, now let me look at positive 2. When I'm at positive 2, I need to go to the right to get to my plus sign. Now, when I'm moving to the right, the x values are increasing. Therefore, we have x is greater than 2. There we are, we have solved the inequality. Life is great. I hope you guys are enjoying the content. I hope that you're understanding it and finding it useful and productive. If you are, please do subscribe to the channel. Please like the video. When you subscribe to the channel, please click on the bell icon so that you always receive an update every time I upload a new video. And most importantly, please share this with others so that everybody can be benefiting from the knowledge that you're learning here. Awesome. Let's go to the next question. Aha. So we've got x squared plus 9x plus 18 is less than 0. Let's look at this one. So, going back to the writing pad, we have got x squared plus 9x plus 18 is, let's see, what was this? Less than 0. Now, when you have something like this, the first thing we have to do is we need to factorize it. So I'm going to have two sets of brackets. This is less than 0. There's going to be x here, there's going to be x there. Factors of 18. I can take 6 and 3. Middle term is positive, so this is plus and this is plus. Now once again, I need to pretend like this is actually an equation. So if it was an equation, I would have x plus 3 into x plus 6. And this would be less than 0. Sorry, we're pretending like this is an equation, so this is equals to 0. When we pretend like it's an equation, our critical values are going to be x is equals to minus 3, x is equals to minus 6. Once again, let's draw our diagram. So there is my diagram, and this is a parabola which is concave up. Once again, this is plus, this is minus, this is plus, always like this. I'm going to put my smallest x-intercept, which is minus 6, and the biggest x-intercept on the right, which is minus 3. Let's have x there with minus 3. Let's have x there with minus 6. Okay, now, notice something. The inequality sign says less than. Less than means I need to check where the graph is negative. Okay, I am at negative 6. To get to the negative sign here, I need to move to the right. When I am moving to the right, the x values are increasing. So x is going to be greater than negative 6. Then, when I'm at negative 3, to get to this negative sign over here, I need to move to the left. When I am moving to the left, the x values are decreasing, so x is going to be less than negative 3, and I'm done solving the inequality. Now please take note, the two blue arrows are facing each other, meaning there's an intersection. So what I can do if there's an intersection is I can put my smallest x value, I can put x, then I can put my biggest x value. What I can do here is notice in this expression, the inequality sign is opening up to the x. So I'm going to open it up to the x. In this expression, the inequality is not opening up to the x, it's in the other direction. So this is go in the other direction. I hope that this makes sense. Life is great, you guys. Now let's look at the last question. So, in our last question, we've got an interesting one. X plus 4 into x minus 3 is less than 0. Let's look at this one. So, let's copy it down. We have got x plus 4 into x minus 3 is less than or equals to 0. Now when you look at this equation, it's already factorized for us, this inequality. So when I pretend like this is an equation by looking at x plus 4 into x minus 3 is equals to 0, what I can simply do is I could say, okay, my critical values are going to be x is equals to negative 4 and x is equals to 3. Let me go ahead and sketch my diagram. That's a terrible arrow. That's still a terrible arrow, but it's a bit better. And let's write our parabola that's concave up. Once again, plus, minus, plus. Always like this. Let's put our smallest x value, which is negative 4. Let's put our biggest x value, which is positive 3. Now, the inequality sign says we are looking at negative. So, let's go to our diagram. When I'm at negative 4 here, to get to this negative sign here, I need to move to the right. As I'm moving to the right, the x values are increasing, so x is greater than or equals to negative, just greater than. Yes, I should be saying greater than or equals to minus 4. Let me put an x there and a space there. Now, when I'm at positive 3, I need to move to the left to get to the negative sign. When I'm moving to the left, x values are increasing, so x is less than or equals to 3. Once again, the two arrows are facing each other. So I could put negative 4 there is less than or equals to x, which is less than or equals to 3. There we have it. We have solved the inequality. Life is great, you guys. I hope that you found this video productive. I hope that you enjoyed it. I hope that you learned something from it. If you did enjoy it, if you did like it, please give us a thumbs up. Please subscribe to the channel. Then after subscribing, click on the bell icon so that you never miss an update every time we upload a new video. If you have any comments, requests, addition, subtraction, multiplication, division, please do leave it in the comment section below and let us know what you think of our content. Other than that, enjoy the rest of your day. Ciao.